Yeah, we'll start the session. So yesterday we have seen what is blockchain, and this definition is from Wikipedia. So just for our understanding, once again, I'm repeating. So blockchain is a continuously growing list of records. So here records means the transactions are the data. So the data are the records are the transactions. We will put it into the blocks. So here block is a container to store our data in terms of records or transactions or data. So these blocks will be linked one after other, and with the what is the advantage if we linked with one block to the other block? So here we are providing security to our data, and we are linking up these blocks with a mechanism or with a existing technology, that is cryptography. So with the help of this cryptography, so we will get a hash code, and this hash code will be linked to the next block. So for every block, right from the second block, so the block contains previous block hash code. So the block may contain any size of the data based on the network configuration of that particular blockchain network. So generally Bitcoin block size is around 1 MB, whereas in Ethereum, the block size, it is around 2 KB. So generally in Bitcoin, we may see there are about 3,000 transactions in a block. Whereas in Ethereum, we may see about 150 or less than 200 transactions we can see in a block. Why? Because in Bitcoin, the block size is around 1 MB, whereas in Ethereum, the block size is around 2 KB. So it is completely a configurable thing by the corresponding networks. So the thing is, the overall picture is whatever blockchain network it is, so we can link up the blocks with the block previous hash code. So now we are into second era of internet. So in this second era of internet and fourth industrial revolution, so blockchain is going to take key role, especially whatever the applications which is depends on data. So even data science projects or IoT related projects, some completely we need to feed a quality data. So if we feed wrong data, definitely we'll get wrong results. So blockchain is going to play a major role to filter out the tampered data or the fake data. So already we have seen this screen in previous session. Anyway, we will just give a judgment or any kind of justice whether really this blockchain meets up the first three buzzwords or not. So some people, they are saying blockchain is a technology. Some people, they are saying blockchain is a database. Some people, they are saying blockchain is a network. But definitely all are correct. So blockchain is a combination of different concepts. So this is a technology, and blockchain is providing us a new way of database. It's a new kind of database. So when we compare this database with the traditional databases like SQL Server and Oracle, so here the architecture is a bit different. So here, with the help of that architecture, we are providing security to our data. And also network, also it is a different network. So we are using distributed and decentralized network. And also it is using DLT, distributed ledger technology. So definitely we can say blockchain is a new technology, blockchain is a new database, blockchain is a new network, and blockchain is using the DLT technologies. So before going to see the actual transaction model, uh, generally when we observe in the popular applications like Bitcoin and Ethereum, we need to understand the key things in the blockchain. So definitely blockchain has a network, and under that network we have nodes. Nodes are nothing but a computers, or we can say peers. So generally these peers, we can call it as miners or validators in Bitcoin and Ethereum networks. So today I will explain, we will go through what is the responsibility of miners and what is the responsibility of validators. So here, these two are having higher responsibilities. So how these two are working on the in Bitcoin network or Ethereum network, and also we need to understand what is ledger and what is block, what are transactions, and what is hashing and encryption. So hashing and encryption, we are going to take up a separate session, in-depth session. And just for at this point of stage, we need to understand these two are the mechanisms, and these two are pretty old mechanisms. So with the help of hashing and encryption, we are providing security to our data in blockchain. So once you apply any hashing algorithm or any hashing function on a particular data, it will give us a hash code. So generally that hash code will be 32-byte format. Say, let us assume this is our data, and whatever data you give, the hash code, it will be generated like this. So here it is using SHA-256 hash function. So this function, we can call it as cryptography function. So it doesn't matter the size of the data. So you can enter 1 GB or 1 TB. Always it will give you a fixed length of hash code. But when you just a small change also, it's a huge change in the hash code output. So this is called it as avalanche effect. Anyway, we are planning to conduct a separate in-depth session for hashing and encryption as well. So that time we'll go more in depth. And what about encryption? So this encryption, whatever data if you encrypt, you can decrypt at the receiver. Generally encryption we will do it at sender side, and decryption we will do it at receiver side. So in between the data the data traveling, so no one can see the exact data. Okay. So the thing is hashing, whatever data you hashed, you cannot reverse it back. Whatever data you encrypted, you can revert back with the decryption mechanism. So the thing is, why we need hashing here? So say, let us assume this is a blockchain network, and there are about 5 blocks. So this is block number 1, 2, 3, and 2 more blocks are there, 4 and 5. So how this block generates this hash code? On what basis this block generates hash code? Is it only on data? Yes. So it is one way, partially it is correct. So block contains data. Number 2, block contains block index. Number 3, block contains block creation timestamp. Number 4, block has previous block hash value. Number 5, it will be output, that is hash code. So when you observe, this hash code is the output of the block. That block, this hash code, we'll call it as a digest value. And how this hash code generated, at least for this block, so based on block size, block index, And nonce value I will explain in few minutes. And data, this is our original transaction. Suppose if we transfer some funds from XYZ to some ABC account, so all the transactions will be recorded over here. So generally data and transactions or records may be interchangeable. So data is nothing but a transactions. And this is previous hash block. So here, if it is a first block in the blockchain or Genesis block, so that block, previous block hash code doesn't have any previous block hash code. So that's why we'll put it as all zeros. And togetherness of all these things, blocks, block index, data, block timestamp, previous block hash code, all these togetherness of all these things, we are getting hash code. Okay, so suppose if I change block index, it is getting changed in the block hash code. Suppose if I change data, it is getting changed. Suppose if I change previous block hash value, that will also impact over here. So why we need hash code here? Suppose if I transfer the data from one location to another location, from source to destination, so no problem. That is one way. Suppose if the destination wants to check, if the destination node wants to check whether this data is genuine data or any tampered data. So generally, how we can send? So suppose if it is 100 transactions data, we need to send 100 transactions. Again, we need to send 100 transactions for the verification. So that's why just instead of sending the data, we are just sending the hash code so that they will check up with the hash code. So let me explain in one more scenario. So this hash code will be linked up with the next block so that the block continuously grows. And currently the blocks in Bitcoin, it is about more than 585K. So this is about 585K. So that the blocks will be keep on growing. And also, if you just click on that block, you will see how many transactions were there in that block and what is the hash of the block and what is the previous hash of the block and what is the timestamp of the block. And also, there are two other parameters, block difficulty and block creation time and block reward. So I will explain all these things in few minutes. And also nonce also. So nonce, block reward, block difficulty. So these three are important things. So we will see it in few minutes. Next, try to understand how this block will be there in a particular node. So if you observe what are the actors, what are the things in the blockchain, first network, next is nodes. So how the nodes or the peers will be connected with each other in the network. So it will be in a distributed and decentralized network. So here networking concepts also coming, and here we are no more centralization. Traditional systems and all, we are maintaining centralized network. So here decentralized and distributed network. So think that P1, P2, P3 are the peers in the network of Bitcoin. So all these peers or nodes are having same ledger information. So L1 is ledger. So what do you mean by ledger? Ledger is nothing but a bank statement, kind of bank statement, and it has a transactions or data or records. So at any point of time, if you see, the ledger remains same for across the network in all the nodes. So here, if there are 100 transactions in the ledger, so here also in P2 same 100 transactions, in P3 also same 100 transactions. So generally the transactions, how it will be stored in the ledger, it will be in the form of blockchain. So ledger is nothing but our blockchain. So blockchain is nothing but our ledger, so it will be exchangeable. So you can think of that, suppose if here there are 5 blocks. So each block contains 100 records. So there are about 500 records or transactions, and same data will be here also 5 blocks, and each block contains 100 transactions and 500 transactions. So here also same thing. Suppose if any new record, any new block added into this ledger from the P1, so immediately that ledger should be validated by someone, and I will explain that validation process. So the newly added ledger, if it is really genuine data, so that newly added block will be added as a 6th block in the blockchain, and it will be broadcasted to other nodes in the network like P2 and P3. Automatically, P2 also will add up that 6th block in the ledger, and also here in P3 also it will be add up the new block as a 6th block. So like this, the data will be stored in blocks, and the blocks will be added up to the blockchain. So here, if you observe, network, nodes, ledger, blocks, transactions, hashing, encryption. At least we have some idea, right? So in nodes, generally, we'll call it as miner nodes and validator nodes. So in a few minutes, we'll see more in depth what are the responsibility of miner nodes and what are the responsibility of validator nodes. So generally in one-liner, miners will add up the new blocks into the blockchain. So before going to add up that blocks into the blockchain, validators first they will check up, and if it is really genuine data, then it will be added into the blockchain. So here, whatever miners creates the blocks, that blocks are called as candidate blocks. So candidate block means it is before validation, the candidate block will be generated from the miners. So miners, they will create the candidate blocks, and candidate blocks are not the original blocks, are the what we call finalized blocks. So these are temporary blocks, and once miners broadcasted that blocks to the validators, they will check up the data, and then only the block will be added into the blockchain. So like that, the block will be keep on growing. So when we compare, when we check up the Bitcoin, so it will keep on growing the size. So from last 10 years, so it is keep on growing the size. So anyway, we'll come back to this to see what are the difficulties, the internals of the blockchain or the Bitcoin application or Ethereum application. So now let me continue this one. So think that here it is a node. Node means a particular person or a particular computer or a server or a peer. So right now there are 5 blocks, and all are having valid data in all the 5 blocks. Next, how the block will be in distributed system. So distributed system means there are more number of peers. So think that the same blocks, block number 1 to 5, is there in different nodes in the network. Peer A, like that, peer B and peer C. So peer A, B, and C are, you can think of 3 different servers, or 3 different peers, or 3 different nodes. Node or peer or server, all are same. So now if you observe from 1 to 5, all these 5 blocks are there in 3 nodes. So if you observe the hash code, so first block hash code is 2CBB, ending with 2CBB, and even if it is in peer B also same data, same hash code, and even in peer A also same hash code. So that's what, at any point of time, if you observe, the data remains same. If it is really valid data, so the data remains same, and at least it will check up the last hash code. Why the last block hash code always? So think that 2CBB, it is linking up with the next block, and the second block hash code is 54F5, and this 54F5 was linked up with this third block, and third block hash code is EB7, and this EB7 is linked up with fourth block, and again fourth block output is 9EBE, and this 9EBE is added up into the fifth block. Suppose if anyone wants to create a new block, so generally what they will do. So here some miner or some peer will be created a new block. That block we will call it as candidate block. And once the block was created by any peer or node, so this candidate block will be broadcasted into the network. And in the network, who are all the nodes? So they will become as validators. So now in this case, if peer C generates a new block, that is called as candidate block, and immediately peer C will broadcast about this block, newly created candidate block will be informed to peer B and peer A. Now peer A and B will check up the hash code, previous block hash code, timestamp, and all these things, and also the data. So this data also, whether it is really genuine or not. So not this block, sixth block. So then once it is finalized, once it is proven that there is no tamper data, then only it will give the block A, peer A and peer B will be informed to the network that everything is fine. So then only the block will be added into the blockchain. So once again, come back to this screen. So at any point of time, I'm not talking about this S, this is smart contract. So smart contracts are not there in Bitcoin. So we have smart contracts concept in Ethereum. We will see that smart contracts in some other sessions. So now at least you need to understand what is peer, what is ledger, what is network. Okay, next. So these are the 5 pillars of the blockchain, and at least at this point of time, we have some idea about what is cryptography or what is hashing and what is immutable ledger. So this ledger, whatever it is added in terms of blocks in the blockchain, it will be immutable. Suppose if I touch, what will be happen? Say, let us assume here there are 3 nodes, peer A, peer B, peer C. Suppose one of the miner, he is going to tamper the data. Say, let us assume he is going to change something over here. So observe that this hash code, whatever it is newly created with the latest data, modified data. So it is 1B9. So whatever he changed, it was impacted from here, from block number 1 to block number 5, it was impacted, and it's all the hash codes are different to other nodes in the network. Whatever hash codes are, whatever blocks hash codes are different in the network, it will be converted as red mark. So that means just it is for our understanding only. So you understand first block hash code was 1B9 in peer A. What about in peer B? It is 2CBB and it is 2CBB in C also. So that means it will easily understand that. So this block hash code was, this block data was tampered by someone. And also, if you just remove the one, 2CBB is there and same 2CBB. Suppose if I change, if this particular miner changes from block number 3. So now in peer A, block 1 and block 2 are valid. So it is matching up with the other nodes in the network, but block block 3, it's tampered, right? So the thing is, hacking is possible, but when you broadcast this data onto the network, then only the issue will come. So other nodes will not accept. So hacking at this point of time, that means that is their control only. So peer or a miner or any node in the network, they can able to modify the data. But modifying the data at his own computer or node, it is not valid. Okay, so once whatever the value, the modified one, it should be broadcast into the network, and other nodes also accept the data. Then only it will be added up or added up into the blockchain. So here it is impossible when you try to sum data in the old blocks or newly created blocks. So that's why from last 10 years, Bitcoin is in a secure chain, at least in data point of view. So no hacker attacks or no any data tampering situations. So it is a public blockchain network, and you and I can join as a miners or peers in the network, and even anyone can join as a retail user, and they can do the transactions. The thing is here, retail users are different and peer nodes are different. So peer nodes are nothing but the servers in the network. So you and I can join as a peers in the network if you have proper infrastructure and proper software. So it's software and all, it's free of cost. You need not to pay anything. But the thing is, you need to maintain a huge infrastructure. We need a high computing powers. So GPU based systems are required. So why we need GPU based systems required? We'll see. So what is the mechanism over here, and why we need high computational powers when you want to join as a peer in the network? And what are the benefits if I join as a peer in the network? So two things we need to observe. So what are the advantages if I join this public network as a peer? And the second one, what requirements from my side and what I need to join as a peer in the network? So number one, it is high computational power you required. And if you add a block into the blockchain, you will be rewarded by 12.5 US dollars, sorry, 12.5 Bitcoins. So let me show you in the practical system of the Bitcoin. So this block was newly created, and this block was created by some peer in the network. So there are about 35,000 nodes in the network. So 35,000 peers are there in the network of Bitcoin across the globe, and at any point of time, the block will be created by one particular miner only. So there are about 585K nodes are there, and all these nodes, 585K blocks are there. All these blocks were created by a individual miners. So if you want to see the miner details also, you can able to see, but the thing is here you cannot identify who is that particular person or the miner. So these are all the transactions. This is the data in that block. So it's a huge data, and also it is in some secret code or hash code. So you cannot see the data directly. Though it is a public network, so identity is maintained without knowing all the details of the transaction, who involved the parties of the transactions also. And here, if you observe the block reward, it is 12.5 Bitcoins, and the today's cost, it is around 142K USD. Okay, so the block creation time for each block, the block creation time, it is about 10 minutes. So that means for every 10 minutes, a new block. So how many blocks per day? It is about 144 blocks a day. Okay, so for every block, the reward is right now it is 12.5 BTC. So that means for every 10 minutes, 12.5 Bitcoins are coming into the network, into the outside. Okay, so actually this reward is not always fixed up. It is varied. So when the Bitcoin was started somewhere in 2009, so 2009 to 4 years, 9, 10, 11, 12, up to 12, roughly I'm saying, not exactly. So the reward was about 50 Bitcoins. So from 2013 to 2017, the reward was 25 Bitcoin. So for every 4 years, the reward is coming by half. So from 18, 19, 20, 21, it will be 12.5 Bitcoins. So next from 2022 to how much it is, 25? 25, it will be half, by half, that is about 6.25 Bitcoins. So the new Bitcoins for every 10 minutes, why the new Bitcoins are adding up into the system, that is the reward, why we are getting reward. So we need to apply some high computational power. So that high computational power we'll see in the next second session. So the thing is, for every 10 minutes, some Bitcoins are coming up into the market. New Bitcoins are coming up into the market. So there is a cap for the Bitcoins. It is maximum 21 million. So after 21 million, once it reaches 21 million, no more Bitcoins. So this process, we'll call it as mining. So for every 10 minutes, whatever new Bitcoins are coming up into the market, this is called mining. So this is similar to like our gold mining and silver mining kind of stuff. So the mining, the purpose of the mining, we are just getting out some what we call raw materials, and from there we will get the original stuff. Like that here, Bitcoins are coming up for every 10 minutes. New Bitcoins are coming up. As per today's scenario, it is 12.5 Bitcoins are adding up into the market. So right now there are, this is the total supply. So 17.82 million Bitcoins. So the cap maximum supply, it is 21 million. So if it is about 18 million, next only 3 more million Bitcoins are there in the there for the mining. And to reach that 21 million, approximately it will take up 2140 year. Okay, so by in next 120 years, the cap will be reached. So hope you understand the mining. It will keep on continue. So from 2026 to around 6, 7, 8, 9, 2029, it will become about 3 point something, 3 Bitcoins. So like that, it will keep on decreasing the reward size. So if you observe, to reach the 21 million as per today's scenario, so by 2140th year, so we may reach that cap. Okay, that is different story. But the thing is, what is the process of this mining? Okay, so this mining we can see after the break, and this mining involves high computational power. So this high computational power, generally it will be incurred a huge, we need to spend huge money if you want to become a miner. So majority of the miners, as per the report, majority of the miners from China only. So you need to understand what one block today's cost, it is about $142K US. Okay, so that huge reward is coming for every 10 minutes, so that you can understand how the miners are, how the peers, how much computational power they should use, and what is the computation among all the nodes. So across all these 25,000 nodes will be participated in the racing to get the reward. Okay, so but there is one chance among all these 35,000 nodes, there is one chance for one particular node, that chance will come to reach that reward. So how we will get that reward, and how a miner achieves that block creation. So once you successfully creates the block, then only this reward will come to your account. So how among all these 35,000 nodes, how a particular peer or a node will win that reward. So what is the mechanism? So that mechanism we'll call it as mining. And there is one more concept called consensus. So these two are very much important things. So mining, just in one liner, I will tell. So the mining is the process to create a new block. Okay, so that block we'll call it as candidate block, and this candidate block will be broadcasted to the network, and that candidate block will be validated by the other nodes in the network. So that validation we will call it as consensus. If 51% of the nodes say yes, then only it will be, the block will be added into the blockchain. Once again, I'm explaining. Anyway, we'll go in depth. Mining means you can try to create the block. So this creation of the block involves all these things. So you need to take up what is the index of the block, what is the timestamp of the block, and what is the previous block hash value, and what is the real data. So real data means the Bitcoin transactions. So all these data you can club up into the block, then you should generate the hash code, and this hash code you need to broadcast to the other nodes in the network. So all these other nodes will validate our block data about all these things, especially data. And if it is everything is fine, then these validators, they will inform to the network. So from individual nodes, they will inform to the network. And if 51% of the nodes accepted, then the block will be added into the blockchain, and then only the miner or the peer will receive the reward points. Okay, so this will take up, the mining and consensus both will take up about 10 minutes time. So generally 7 to 8 minutes time for the mining, and 2 to 3 minutes time for the consensus. So togetherness of both mining and consensus, that we'll call it as block creation time. So we are talking about Bitcoin. So in Bitcoin, the block creation time is about 10 minutes. So in that 10 minutes, 8 minutes is for mining and 2 minutes is for consensus. Once again, we'll come back, we'll see in depth of mining and consensus. So in 1 minute, the session will be closed. Please rejoin the session.